Good afternoon. Today we're going to move from numerical expressions into algebraic expressions. So if you'll turn in your textbook to page 449, and when you get there, go ahead and scan the lesson and find two real-world scenarios where we're going to use variables and expressions. Pause the video and go ahead and do that, please. Here are a couple of examples of some real-world scenarios you might have found. Could be to find speed when we know distance and time, to find the cost of something when we know the total and the cost of the other item purchased. There may be a variety of answers that you found as you were looking through this chapter. Let's take a look at the vocabulary startup. This vocabulary is very important. We have been working on some algebra skills, but these are specifically going to become algebra that we're working on. Algebra is not a scary thing, okay? I don't want us to be afraid of that word. Algebra is a language of symbols, including variables. A variable, remember, is the symbol that takes the place of a number. So for example, variables you might have x, you might have n, m. It doesn't matter what the variable is. I typically use a variable that starts with a similar letter. So if I am using it to represent a piece of cake, I might use a C. If I'm using it to represent pi, I might use the P. Okay? It's a lowercase letter that we're going to use to represent and take the place of a value of a number. So let's fill in this graphic organizer here. I want in the first box with a math meaning should be the mathematical definition, okay, in student-friendly terms. Okay? Everyday meaning, what does variable mean in the real world? Okay, outside of math, what does that word variable mean? You might even think about science there. I want you to give some examples. I want you to give me 3 examples of variables. And then non-examples should be something that wouldn't be a variable. And I want you to give me 3 examples there. And don't give me something like a dog or a cat. Give me a mathematical thing that would not be considered a variable. Almost like the opposite of it. Okay, go ahead, pause the video and fill that in at this time. Okay, here are some examples. You could have said a symbol, usually a letter used to represent a number. It could be every day, it's the ability to change or vary, like variable wins in a science experiment. A variable would be the thing that could change depending on the conditions. Examples might be X, Y, or A. Okay, here you could have M, P, K, whatever you chose. Non-examples would be any numbers. So 3, 6, -10, 2/5, 36%. Okay, those are not variables. Those would be non-examples there. Okay, let's go ahead and take a look now at our real-world link. A box contains an unknown number of markers. Unknown. Okay, that's making me think about a variable there. There are 2 markers outside the box. The total number of markers is represented by the bar diagram below. So here's our unknown. We don't know how many that is. Okay? We could call that one of our variables. Let's call it M for markers. Okay, outside the box though, there are these 2 markers. Okay, so we know we have a 2 here. So suppose there are 14 markers in the box. So that means that now instead of M, this became a known value, which is 14. Find the total number of markers. Well, obviously to find total, we would add these together. 14 plus 2 would give us 16, and then explain your answer. So take a minute, and I want you to explain how you got 16, how we got 16 together. Okay, and let's go ahead now to page 450. This is really where the meat of our lesson happens. Okay, we're going to look today at one-step expressions. Later on, we will solve some 2-step expressions, but for today, we're going to look at these one-step expressions. Algebraic expressions contain at least 1 variable and at least 1 operation. Remember, because it's an expression, that means that there are no equal signs. Okay? When it's an equation, then we'll have equal signs. So for example, the expression n plus 2 represents the sum, answer to an addition problem, of an unknown number, which is in this case the n, and 2. That's an expression. The letter x is often used as a variable. X and y tend to be Two of the most common, C is pretty common. Okay, to avoid confusion with the symbol X, there are other ways to show multiplication. So take a look here. We have talked about using the dot. Okay, so this method should not be new to us. So this still means 5 times X. Okay, this one might be slightly new. When we smash together a number next to parentheses, that also means to multiply. This still means 5 times X. Okay, just as 5 times X was over here with the dot. This is the one we are going to use, okay? This is the best one. In algebra, if you see a number and a variable smashed together like you see here with 5x, that means 5 times x. And this is probably the most common way we'd show it. 3m means 3 times m. 6d means 6 times d. Okay? The variables in an expression can be replaced with any number. So if they tell us in this case that m is 4, this would really mean 3 times 4. And then we can find the value. When it says you can evaluate, that means we're going to find the value of the algebraic expression, or we're going to solve. Okay? To evaluate just means another way to say solve. So let's take a look at some examples. Example 1 says to evaluate 16 plus b if b is 25. So we have 16 plus b. We're going to replace b with 25. So now we have 16 plus 25, and that's going to equal 41. That would be our solution to that example. Okay, number 2, evaluate x minus y. So we have x minus y. If x is 64 and y is 27. So we substitute those in place of the x and the y. So now we have this expression. We solve, we get 37. Take a look at example 3. Now they're going to add some fractions in. Fractions are our friends. We're not afraid of them. They said to evaluate 6x. Remember that 6x means 6 times x. So we're thinking about that in our mind. So this means 6 times 1/2. Thinking back to our work with fractions, this would become 6 over 1 times 1/2. We can cross cancel. That'd be divided by 2 is 1, and divided by 2 is 3. So 3 times 1 gives me 3. 1 times 1 gives me 1. So that would just be 3. And if you think back, half of 6 would be 3. So that makes sense. Let's go ahead to the got it's. I want you to solve A, B, C, and D using the information above. Okay, evaluating those expressions with those substituted values. Go ahead and pause the video at this time, do those 4 problems, and then check back. If you take a look here at the solutions, we're substituting. A was 6, so 6 plus 8 would give us 14. In B, A is 6 minus 4 gives us 2. In C, 6 times 4 gives us 24. And in D, this is 9 times 1/3, so that'd be 9 over 1 times 1 over 3. Cross cancel 1 and 3. Gives me 3 over 1, which is just 3. If it's not making sense, go ahead and rewind, look back through this, try to resolve some of these. If you're feeling comfortable and confident, let's go ahead and proceed to page 451. Now we're going to evaluate multi-step expressions. Multi-step meaning more than one step, but that's okay, we can do that. We just have to remember that now, since there's more than one step, we have to follow order of operations. Parentheses, exponents, multiplication, division from left to right, and then addition, subtraction from left to right. So we're keeping that in mind as we solve. Take a look at number 4. Evaluate 5t plus 4 if t is 3. So 5t plus 4. I'm not a fan of the variable t because it can get a little confusing there, but it works. T is 3, so this really means 5 times 3 plus 4. Well, in order of operations, I don't have parentheses, I don't have exponents, but I do have some multiplication division. From left to right, I'd go 5 times 3 is 15. Then I'd add the 4, which would give me 19. Okay, look at example number 5. In example number 5, we have some exponents. So we have 4x squared, and x is going to be 1/8. Now be careful here. If they put the parentheses around the x, saying that x is squared like this, that would mean just the x. Sometimes they may say 4x and that part is squared. In this particular problem, this exponent is only going to the x. Okay, so in 4x squared, we're putting 1/8 in for x, so we're squaring 1/8, and we still have that 4. So 1/8 times 1/8 gives me 1/64, and then we have to put that here. So this becomes 4 over 1. We're still multiplying. 4 divided by 4 is 1. 64 divided by 4 is 16. So we get 1/16. That would be our solution to that expression. Take a look at number 6. Evaluate 10a plus 7 if a is 1/5. So they've done a little bit of work for us. Let's fill in what we know. So we're replacing a right here with 1/5. So we still have the 10 out here. 1/5 goes in parentheses plus 7. Well, I need to multiply 10, which is 10 over 1, times 1/5. I'm going to cross cancel, which will give me 2 over 1, which would just be 2. So 2 plus 7 would give me 9. Okay? Go ahead, and I want you to try these got it problems here at the bottom of the page. You have E, F, and G. Using the information above, you evaluate these expressions if D is 12 and E is 1/3. Go ahead and pause the video, and then we will check back in a minute. Okay, if you look here, we have 2D minus 5. That really means 2 times 12 minus 5. So that would be 24 minus 5, which gives me 19. Four-letter E, sorry. Then I have 50 minus 3 times D, which is 12. So that'd be 50 minus 3 times 12 is 36, which would give me 14 for letter F. And then I have 9e squared. Well, E is 1/3, so I'm going to square the 1/3. That means 1/3 times 1/3, which would be 1/9. I still have 9 over 1 times 1/9. I can cross cancel beautifully here, which gives me 1 over 1, which is just 1 for letter G. If you need to go back and review or watch a few more of these problems, go ahead and do that at this time. Go back through them. If you're feeling comfortable and confident, let's proceed to page 452. On this page, we have this word problem. Okay? Khalil is wrapping a gift for his brother's birthday. The box has side lengths that are 1/2 foot. Use the expression 6s squared, where s represents the length of a side, to find the surface area of the box he's wrapping. We'll work more with surface area a little bit later this year, but remember, surface area is finding the area of each surface. So you have this surface, you have this back surface here, you've got the back surface back there, this surface on the side, you've got the top, and then you've got the bottom. So there are 6 surfaces in this cube, in this gift box. So that's where the 6 comes from. And then we have s squared because each side is side times side. Okay, so if we're looking at this one, I'm multiplying s by s. So this is s and this is s. Well, s times s gives me s squared. Okay, so in this case, we're just going to substitute that value of 1/2 for s. So I have 6 times 1/2 squared. So 1/2 squared would be 1/2 times 1/2, which gives me 1/4. Now I have 6 over 1 times 1/4. I can cross cancel, so this would be 2 and 3, which gives me 3 over 2, but that's an improper fraction, so we'd get 1 1/2. Because it's surface area, we're going to have square feet. Okay, and you see that here. The surface area of the box is 1.5 square feet. Okay, I want you to take a minute and go ahead and do the guided practice problems here. I'd like you to do 1 through 7. So go ahead and pause the video. If you're feeling comfortable and confident, go ahead to proceed to these. If you need to go back, do that at this time. Let's check our work here. On this problem, 3 plus m was 4, so we had 3 plus 4, that gave us 7. Z minus m is 9 minus 4, which gave us 5. 12r, 12 times 1/6, we have 12 over 1 times 1/6. Cross cancel, we get 2 over 1, which is just 2. 4m would mean 4 times 4 minus 2, so that would be 16 using order of operations. Minus 2 gave me 14. 60 times r, which is 1/6, minus 4. Well, 60 over 1 times 1 over 6, cross cancel, would give me 10 minus 4, gives me 6. And then 3 times r squared. So r is 1/6 squared. So 1/6 times 1/6 gives me 1/36. And then I still need to take that times 3. So 3 over 1 times 1 over 36. Cross cancel, I get 1 and 12, which would just give me the 1/12, which you see here. Take a look at number 7 with me. You should have gotten $8. The amount of money that remains from a $20 bill after Melina buys 4 party favors for P dollars. So 4 party favors for P dollars is 20 minus 4P. So 20 minus 4P is their expression. Find the amount remaining if each favor costs $3. So we're going to substitute that $3 in for P. So we have 4 times 3, and then we're taking that away from 20. So that would be 12. 20 minus 12 would give me $8. If you're feeling comfortable and confident at this point in time, I want you to proceed to page 453. And on page 453, you are going to do 453 and 454. (1 through 14), and this is due on Thursday. Okay, we will check this one and your numerical expressions with order of operations both tomorrow, so make sure both are ready to go. If you are finished with this, when you finish, keep it in your textbook, and then you may continue on to work on those IXL skills. Remember, the IXL skills were emailed to you. They can also be found on our homework link page on the Bond Grant website. So if you scroll over, they're right here for our class, and you're working on any of those. Okay? Good luck on your homework. I'll see you tomorrow.